speed and confidence are two very critical elements that every engineering team in a startup tries to strive. However, there are many roadblocks, many challenges that we face. So, from my experience, whatever I've learned, I would like to share my thoughts on this topic. So I'd like to, quickly get started. I'm just sharing my screen. Hope you can see my screen, everyone. Can anybody just confirm if they can see?
Yes.
All right, cool. Thank you so much. So achieving speed and confidence with testing, a very important topic for many of us. And to set the ground, what is it really? What is it really? That I mean by achieving speed and confidence with testing. What's speed to begin with? Speed is defined as the rate at which something happens or something is done. And what is confidence? Confidence is a state of feeling certain about truth of something. What that means is that also means that you are sure about something. You don't have any fear, or you're not nervous about something when you're confident. Now the question comes: we want to achieve both. We want to achieve speed. We want to achieve confidence. But is it really possible? To understand the answer of this question, whether it is possible or not, let us first understand the dynamics, the environment in which a software team functions. So, in any software development project, be it startup or be it any enterprise, there are three parameters which typically influence us: schedule, scope, and quality. Schedule is the timeline, the deadline, whatever you want to call it. Scope is the amount of work that you need to accomplish, the number of stories or the requirement, etc., etc. But that's the scope of work that you need to finish up. And third is the quality. Quality of the delivered release, delivered build product. That takes an effort to achieve that. But the reality is, from years of experience, I've realized that we can at one time only achieve two parameters successfully. The third always happens eventually. What I mean by that is that out of the three parameters, you can strive your best to lock down two parameters, but the third one, you would have to sort of strike a balance with any of the first parameters, first two lockdown parameters. So what happens is that we define schedule, that this is the day we want to release. Then we define, okay, these are the set of features we want to release, and then we start working on it. And when that happens, in that race to finish up that set of features in that set of quality, in that set of time frame, often the quality gets compromised. Why? Because we are so much interested in doing so much that in that given period of time, that we end up many a times compromising on the quality of the product. Now, okay, so and why does that happen? So what is it about quality? Why is it so hard? Why is it that we struggle with it? From my experience, I've realized, and many people do in software industry, that it is the nature of the software development itself that it is an intellectual creative process. Think of it like writing an editorial article or doing some research project. We are doing some analysis or any such strategic activity. Now all these things take time. It needs to go through multiple iterations of improvements, of everything, then only it gets perfect. Um, because since it's a creative one, we think about it, we do it, and then we match it with whether what we thought it turned out to be the way we wanted it to be. And specific to software is that unless you see something in your hand, unless you see something with your working, you really don't strike and connect with it. You don't really strike an engagement with it. So without an engagement, there is no adoption or no feedback possible. Otherwise, it just becomes a theoretical exercise. So to make it practical, we have to develop it. We have to release it, and that is a process. Many a times that we get trapped into balancing the three parameters: scope, schedule, and quality. And many a times, quality is the one which suffers. So moving on. Why is it important to achieve speed and quality both? Because the criteria of achieving speed and confidence, I personally feel boils down to how we balance our pace of working and the quality of the software that we are developing. But it's important to establish that why is it that we require it. As a developer, why should I care about it? As a tester, why should I care about it? Or as a product manager, why should I care about it? It is important for multiple stakeholders. One, for customers. Customers today, we are all customers in our individual capacities, and customers, they want new features. We want cool features. We want features which work flawlessly all the time, so that we can depend on them, we can use them, we can find the products trustworthy. For any business, speed is important because they want to move fast, they want to grow fast. They have some business pressures of any revenue timelines, or GMV targets, or on the other hand, there could be some competition pressure or any other factor which generally is important for them. And many startups in our situation have limited funds under which they operate. So the longer they work, they take to develop their feature, it's more economic impact for them. On the other hand, for a product, like I said, it's a software development is an intellectually, creative process, which is an impact on the product itself. So any product that you see today, it's continuously improving. Even Google, even after 20 years, more than 20 years of development, it's still, progressing, because new cases come, new situations arise, new demands are there. So we need to continuously enhance our product. And if that pace is slowed down, it's going to impact the product, ultimately impacting the business. Fourth, engineering teams. For engineering teams, it's so very important that if they are able to establish this balance, they will be able to create a very efficient working models, a very healthy engineering culture, and they can stop, wasting their times on avoidable defects, avoidable downtimes, incidents, rollbacks, etc., etc. So all that chaos can be reduced. On the other hand, the opposite question, that comes to the mind is, what if we don't get this right? Again, impact of the organization and impact on the engineering. Impact of the organization is that they would miss product feature launches, they would miss their sales timeline, they would have financial crunches, financial challenges to support the staff that is being hired, or whatever expenses that they need to do. Poor quality of the product leads to a situation where customers would start abandoning the product. They would not feel like using it because it's not really worth it. Which means that whatever the money the company has spent in marketing the product, that goes down the drain. There is increased pressure on the customer support team, because the customers are facing issues and they have no one to reach out. So there's a volume of new customer queries that come, grievances that come. So those teams face that pressure. And it becomes an impediment for the organization to compete in a competitive environment where other companies are competing for that. On the other hand, engineering, faces the impact that they end up in inefficient situations where a lot of time is getting wasted doing unnecessary stuff or stuff which can be done in a smarter way. Often, issues such as this lead to blame games, culture getting deteriorated. People stop enjoying working in such organization. People quit, and that itself, creates a mire of problems, and overall leads to a lot of unpredictability in the team. So the next question that comes is, so if we all feel about it, if many of us feel about it, why are we not doing this already? Why is it such a challenging situation for us in our situation? I would say that one of the reasons is that software industry is relatively a young industry. Software industry as an industry started, I'd say, 50 years back or so. Before that, the software or computers were part of the research or very top projects, those kind of situations. But it came sort of a mainstream since last 50 years, and the nature of software is that it is producing technology, and technology is disrupting at a very fast pace. And we are all today, we do not need a conference hall to have this kind of a show. So technology is changing the way it is happening, and technology is disrupting technology teams as well. The way engineering teams were functioning 20 years back, they don't function today. However, if you compare that to the way other industries are working, for example, mechanical engineering or medicine or accounting or maybe food industry, uh, such rapid changes haven't been happening in those industries as well. And the way many software teams are created, are designed, they are not really designed in a way that they embrace the change. They embrace the fact that because we are a young industry, the knowledge of one generation to the other generation is going to get passed over a period of time. Change is inevitable, change is bound to happen, and embracing the change, being flexible to adopt the change, being open to adopt the change, has not been thought through as the essential ingredient for that engineering team. People are still fixed on the way that they want to function in future as well. So okay, so coming back to the point that how do we improve our quality, and part of quality is testing, and I would like to spend a few minutes on that. um, so how can we improve our testing, to understand this point in a bit detail, in a bit first principle way. um, you know uh, Basically we define the parameters under which we work. Speed, like we established earlier, is a steady pace, a sustainable pace of software development which a current team can sustain over a period of time. It's not being rash, it's not being crazy. It's more important to have a sustainable pace which you can maintain without your team having burnouts all the time, or late evenings and weekend working. That doesn't sustain over a period of time. Sometimes it's okay, but it cannot sustain. It cannot be a norm. People wouldn't like to work. People would like to have work-life balance. So it is important that we establish an environment where there is a steady pace. Quality, definitely quality has to be met. That is what is the need. And quality has to be evaluated from both usability as well as a technical standpoint. um, okay, moving on. Another thing that we need to understand it, what is it that we are trying to optimize on a bigger level. The on the bigger level, what we are trying to optimize is lead time. What I define lead time is the time when the business gives you the requirement. Business or product team, whoever takes a shot in your organization, business gives you the requirement, and the time that is made available to the target customers. That is sort of a lead time. A lot happens, between the moment the requirement is tabled to a product team, then they evaluate, then it comes to tech, there's collaboration, and then development, release, and test. But for the focus of this this talk, I would like to focus on the lead time that is available at the engineering, and specifically focusing on the DTR cycle, develop, test, and release, and focusing on the test phase of that. Uh, a general semantics about this is that development, test, and release. These are three phases. Out of them, development, which is something an intellectual creative work which happens, which will always be sort of a manual thing. Testing is something which is done manually, as well as there are ways by which people automate it. And release is something which generally DevOps or SRE or infra team takes care of. There are ways that they do manually, but of course they have their own 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 growth of how they can automate it. There are so many solutions coming out in that domain as well, how they can make the release process more smooth and more painless. So focusing on testing. So how can we improve our testing? I personally feel that there are four things that we need to get it right if we have to focus on getting the right testing. First is adopting the right orientation. Then is adopting the right culture in your engineering team. The third is adopting the right strategy for the automation. And fourth is doing the automation the right way. Okay, so let me explain. Adopting the right orientation. The very foremost, which I personally found that is the most impactful is prevention over detection. Now, majority, many engineering teams, organization ask that what is the job of a tester? What is the job of a QA? Is it to find bugs, or is it something else? Now, and that is one of the fundamental factors why I would say the processes or the practices of testing are not really so much, the best practices are not really so much prevalent, is because this is sort of a mental barrier which has limited the adoption of right strategy towards right orientation towards testing. The job of a tester, in my opinion, is more to prevent the bug than just to detect it. And that is, I would say, that orientation change propels a tester to think in a ways that they want to go one step further in understanding how any software is made, how it is created, why it is created, so that the end quality goal from a technical and usability standpoint can be achieved with high quality. And that is point number one in this. Second, automation. Neil Ford is a speaker, a renowned speaker. He makes a joke about this, that computers are meant to be are created to be doing repetitive, boring, manual tasks. But although in the software industry, softwares are created to cut down the manual work of the rest of the world, the software industry in itself continues to function this part of their development phase manually and are not applying the automation to themselves. That's sort of an ironical joke that he creates, that he says. But I totally agree with him. I totally align with that thought, that though we are creating systems and technical systems as a software industry, but we are not applying that to ourselves. So having a mindset of automation, why I say automation three times, is that kind of a fanatic, to some extent, If we take it to that level, then only we'll be able to break through of our current inertia, and change our orientation, where we see everything automation first, and then manual secondary. Third, in this orientation is collaboration. Collaboration is so very important, because software development in whole is not an individual game. To give an example, it's not about one person doing an excellent job, or like in cricket, we see that it's not about those just one batsman or one bowler doing a great job. It's about all those 11 people coming together for a mission, for a goal, and contributing in their best capacities, sometimes complementing each other, and doing whatever it takes to achieve the victory. That is the kind of thing that is many times missing in many teams. We many times get siloed. We don't think on a team level. We are more thinking on an individual level. And fourth, perseverance. It takes time, it takes stamina, and it takes patience and hard work. So as we think about improvement doesn't happen overnight. It takes time, because, like I said, we are all intellectual thinkers. We are all intellectual people, and it takes time for us to change our habits, current thought process, current understanding, and change to the understanding which will lead to a success in future. Adopt the right culture. I would say, again, stressing on the point that quality is everyone's responsibility, is not someone's job. It's not that only tester is responsible. It's developers or product managers, or even the business people or DevOps or SRE. They are all equally responsible, because we are all part of the same team. We are not separate team. And now with it's not to, I would say, shrug off a responsibility that I'm saying this from the tester's standpoint. What it is really when everybody comes together, because when more than one mind are working to improve the quality of something, the collective impact of the thinking always leads to a better result. Simple as that. And that is which has to change in our culture, that quality is everyone's responsibility and not someone's job itself. um, in some companies, some teams, developers both are responsible for development as well as their testing, and in some teams, we have separate testers or SDETs or QAs. So applies in both the situations. For us to adopt this culture, it is very important that everybody raises their game, and be more conscious, more responsible towards enabling quality. And for us, it is important that the developers raise their quality of the first cut that they release as for internal testing. First cut, an alpha release that we call it. So one of the crucial things that I found in enabling success in this is adoption of test-driven development by developers. It's a misconception I've heard many times that it slows you down, but the truth is it doesn't slow you down. It requires initial investment to develop a style of coding which is more congenial for the overall quality of the software. But once learned, it just becomes a part of your habit. Think about it. If you have to learn a database, if you have to learn a framework, if you have to learn any language, you put up some time. It doesn't say that it will slow you down, because to develop a comfort in any language or any any new technology, you need some time. And that is part of our job, because we are learning every few months, every day, in fact. And another point is, on the collaboration side, have a discussion around test cases between testers and and the developer itself, so that it's more of proactively seeking a feedback, which helps the developers understand what could be the possibility or what are the cases which they should take care in front. With if they are aware, they'll be able to write better code, because they know that all these cases I need to be mindful of as I'm writing my code. So that kind of a collaboration would happen. An initiative which should be taken by developers. Testers, on the other hand, should understand how things are implemented, because if they don't understand how things are made, they won't be able to identify where things fail. So investment in upskilling your testers and investment in educating your testers would be so much helpful. If your testers are already aware of how things are done internally, great. But that is not which happens generally across all the industries, all the engineering team, and that is the reason of my advice here. Involve product owners or managers for early feedback whenever necessary. This helps improve acceptance success. One part is doing things technically correct. The other part is doing what was required to do. That those are two different things. And getting early feedback that are we doing what we really were intended to do, not talking about how we were to do it. It's very, very important for acceptance of the software. Talking about the right strategy for automation, there are certain questions that comes to our mind is, what all should I test? What all should I automate? But before automation, because automation is essentially transitioning your manual activity to a machine, it is first understand that if from a manual standpoint, what are the things that we are testing? What is our scope of testing? Now, this is a testing quadrant idea, which was initially proposed by Brian Merrick, in 2006, where he talked about 4 quadrants of testing, and right from moving in a clockwise manner, that should be the sequence of how we should attack them. So, first unit test, then acceptance test, exploratory test, and then property testing. And these are different facets of each of this block that enables us to attack it from an automation standpoint. So unit testing and acceptance testing can be targeted with programming. We can automate them. The other do have technology interface, but we have tools which can help us do that. And one is business facing, so you understand what is the business impact. The other is the critique of the product, where you can check the non-functional requirements or other aspects of the product. Another is okay, how do I plan for automation? So I understand that there are so many things that need to be done. How do I plan for that? Because just so much that could be tested. So this is, and how do we go about it? So this is what is my recommendation on how do we put this. This is a test pyramid, a concept which I which was originally proposed by Mike Cohn, who introduced this concept in somewhere 2004 or 2006, and he proposed that we divide the kind of tests that we do in different categories and target them, so that our level of confidence becomes gradually high as we spend time building these layers into the application. And as I talk about unit test, component test, integration test, performance test, I have attached the from my side what I have seen working in my experience, the teams which should be responsible for ensuring that these are automated. So unit tests is writing your unit tests which are at a functional level, so that you are writing your tests in the right manner. You're writing your code in the right manner. You're covering the smaller nuances of scenarios. Component test is at a particular module level or a service or a microservice level, where you want to test whether the microservice is doing what is expected to do by stubbing the dependencies, the external services, the dependent microservices, or the database, etc. So that is, a component test where you're just focusing on one particular piece, but in a bigger scope. Integration test is something which means that you have your module, you have your microservice. How does it play well within a larger ecosystem? Because any product or any software system is a combination, a collection of multiple components working together in a smooth way. And how any change impacts the other components which are connected, which are either dependent, or this component is consuming the other component. And this is what is integration testing is. Performance testing, as it is clear that how performant is, what is the latency, what is the throughput, how many users can it process, what is the time that is taking per API at a particular load. This is very important. This is something which I really have put dev/QA, because different teams are oriented in a different way. However, I personally feel that this should be under the ownership of developers, because it gives them a very important feedback and insight around whatever code that they're writing, whatever designs that they have, design choices that they have taken. How does it impact the performance? Conducting the test is one important, but taking a feedback and improving on the performance is another thing. So if the same person is enabled to do the test, as well as collect the feedback and change the code, so that the next time the test we do leads to higher performance, is so very easy and convenient and learning experience. That's why I propose that it should be with the dev, but different teams do it different way. End-to-end test is we want to do an end-to-end test of whether through a UI interface or a mobile app, anything that could be there. Or if you're just dealing with APIs, you deal with just the API layer, whether the end-to-end APIs are working fine and not the responses coming just the way that you want. And some manual tests, which are your exploratory tests. You want to add on, you want to think more around the cases which you might not have thought. So those are your manual tests. Another thing is that how should I generate my test data? Because as you think about testing is about what we are trying to test is that there is a block of logic. The input is an event or a data, and the output is another form of data which is coming out. But what the logic does is it has some state, it has some original data, and it takes a combination, takes input data and its own reference data and applies some logic of it, and then gives out an output data. Now, because the component is applying logical analysis on, or logical operation on input data and its own reference data, if we mutate the reference data, we can create different scenarios and different logical situations for the module, for the application, and then that can lead us to different responses. So it is thus becomes important that we are able to create multiple references of the test data. So different classes can be categorized. Many times people feel a bit stuck on what is the right thing to pick in our automation backlogs. This is just a quick tip from my side. Evaluate on two ideas: effort and impact. High effort, low impact, just deprioritize. Low effort, low impact, drop them, don't do them. Low effort, high impact, do it immediately. High effort, high impact, think carefully. Might be you have to find alternatives or need to break down or defer for now. Think about it. So another thing, do automation the right way. Some behavioral expectation that should be from an automation suite. It should enable devs and testers to collaborate on the development of an automation suite. Why? Because again, it comes down to the orientation that quality is a responsibility, is not a job. Should cover functional as well as non-functional aspects, definitely. Should enable devs to get a faster feedback. Very, very important. If your CI/CD pipeline or any other thing is not working, there is no value add that your developers are going to do, and the quality of the first cut build would always be lower because the developer doesn't know until that gets tested. And lastly, should run successfully on multiple environments. We have multiple environments: local, test, or staging, pre-prod, UAT. Our an automation suite should be able to support that. Okay. Then another thing, some technical expectation. It should be written with the same sanctity as you write your own actual code. Actual production code should be maintainable in the long run, because we are not talking quality which is just short term objective, but it's a long term objective. Should support execution from multiple sets of data. No hard coding should be there. Some challenges that I have seen in my experience. Use the right tools, like language or framework for the job. Don't be rigid on implementation, but be rigid on success. What matters is that how fast we can get a feedback of whatever we are written. It should not be how we have written. Of course it is important from long term maintenance, but give preference to the success of it than being rigid on the implementation. And as you go along that journey, you would find that again you will find some repeatable pattern in your automation framework. So if you're able to find repeatable patterns in your automation framework, try to automate your automation as well. That might sound a bit spiky, but it many times happen that if you're doing automation the right way, you will find a repeatable pattern in your automation suite itself, and you can possibly automate your automation suite as well. Sounds cool. So it should be easy to achieve, is it? Not really. There are many challenges or anti-patterns we face. People challenge, first of all, where testing is not considered as a confidence phase, but more as a verification phase. I just want to test it. I know I've done it well. That doesn't happen, because development is an intellectual job. It has to go through a confidence phase, not just a verification phase. Devs think that their job is development, and testers think their job is testing. It comes back to the original point which I mentioned around orientation. The tester's job should be how they can prevent bugs than not just to catch bugs. To increase speed, many teams just think, okay, we need to move fast, let's just hire more testers. But sadly, that doesn't work, because the more people you have, the more chaos it brings to the overall engineering team. And if the team is not set up for success with small set of people, they will not be successful if we have more set of people. In some companies, there is a cultural problem that devs are given higher value than testers. I don't think that is the right way to look at it, and we should embrace a change where we give equal value both to development as well as testing. Then developers and testers don't collaborate. Both teams often have friction between them, primarily a combination of existing problems that I mentioned, that they are working in different teams, they have different expectations, they are incentivized differently, so it creates friction in both the teams. And lastly, developers are reluctant to own up to their development quality. This is one of the challenges which I personally feel in sensitizing developers to own their quality in a more higher way, more professional way. Writing test-driven writing unit tests or writing component tests, being understanding that quality matters more than what we think it matters. That is one of the mental blocks I've faced a lot with my engineering teams. Some process challenges that you might face in your respective teams: technology-oriented team rather than mission-oriented multifunctional team. You have one separate development team, one QA team, one DevOps team, but the challenge is that the communication and collaboration breaks down when we have siloed team. People start creating sort of I would say barriers. If we break those barriers and organize ourselves into one purpose-oriented team, then that would be very, very important. Automation is done by a separate or dedicated team or a person. This is another, I would say, an anti-pattern. Automation has to be, when I say automation, the overall, test pyramid automation. It has to be, owned by all of us, all the engineers. It's not to be, just handed over to one person. Automation is consumed by testing team and not done by dev team. This also happens at many places that, automation is done by, because the QA is doing, so they would just use it because they want to cut down their regression manual effort. No, it has to be handed over to QA and devs so that devs can use it on a daily basis. Automation suite is executed from a tester's machine and not from a build server. Happens some places, not some places, but just wanted to highlight that, this is something we should change. And lastly, testers are identified for finding bugs and preventing them or reduce the test time. Again, prevention is more important rather than just finding the bugs. Some technical challenges that you might also face: development code or application design. It doesn't support ease of achieving test automation. That is one of the most commonly seen anti-patterns I've observed, that the way the things are designed, architected, it doesn't really, are there. So automation suites are designed to run on multiple environment, are not designed to run with varied test data. So that's, thing as well. And knowledge challenges, just in the interest of time, I'm rushing through it. Testers don't feel confident with their programming skills. Testers don't fully understand how the application is developed. Testers don't know how to measure effectiveness of their test automation suite. Testers don't fully understand how to take the right decisions for their automation suites. And testers don't have proper test case repository for documentation and management. So these are another few set of challenges that you might face. So how to start a journey? Management commitment. It's a long-term game, require management commitment and support. Typically, automation's project would take a few months for it to show results. Promote a culture of collective responsibility of quality. And as you think about it, think big but take small steps. Make small progress which can demonstrate value. Make automation usable in daily use, daily runs, daily cycles. Collaborate with devs to enhance your automation suite's quality and effectiveness. That would be very valuable for testers, if that is the case. And evolve your automation over a period of time. And lastly, build, measure, learn, and then evolve. It's a journey. It's not a milestone. It's a journey. So wish you all the good luck for that journey. Thank you so much. That's what I wanted to talk to you. Thank you. I'm open to any questions. Feel free. Thank you.
Thank you, Sarthak, for this talk. It's wonderful to know about testing. And so right now we are running just out of time. So I will just directly jump to the questions that people are asking. Let's just see. Okay, so for startups, what is the first step to move into this journey of testing, and when should they think about it? So if I add to this question, there is a lot of things already going on in startups which needs to be prioritized, and testing almost always takes a backseat. So when should they start thinking about testing seriously, and what are first tiny steps that they can take?
Testing, automation, and overall working towards speed has to be day one priority. Speed cannot be compromised for any startup. However, there is a balance that needs to be struck, and that is what I wanted to say in my last slide, that it's a management commitment that you need to have, where your management understand that it's a long-term game that we are doing. The purpose of testing is not to just to fix bug or reduce their own manual effort. It is to prevent the issues, prevent the problems that might come. And for that, we need some active collaboration. We need some changes. And that needs to be explained to your management, that what are the value adds that you can seek from creating this kind of a program, not just a project, but a program where we all own up to quality. We all own up to contributing towards automation. We all own up to reducing the bugs, preventing the bugs, then finding them. So I would say day one.
Day one. Okay, great. So to the audience, you can ask the questions. Right now, we won't be able to get you live because we are just running out of time, but you can ask the questions in the chat. And it will be better if you ask the question at live.gitcommit.show, because that's what we are tracking the most. One more thing I would like to quickly ask is about the tools that are involved in the testing. So what are the first tools that people should get familiarized to or should get started with for people who have never experienced anything related to testing before?
See, like I said, it has to be a decision based on what can work for your team. It is not one size, one medicine for all the problems, I would say, because importance is collective ownership. Now, if your team the collective ownership as a culture is possible, then take the technical decisions which can enable your developers and testers to work together. However, if that is something which you feel is not there, take the technical decisions which can enable faster movement, where you can move faster with small iterations over a period of time. Evolve your automation, so don't be fixed on the implementation, be fixed on the success. If using some tool or some way you can demonstrate or you can achieve some automation or speed today, take that. Feel free to refactor your code 3 months down the line or 6 months down the line, but don't be afraid of refactoring. What is important is that you should be able to move fast. It should be able to give you value. Should be able to give you confidence, and feel free to refactor your code, replace your code, because what situation would come 6 months down the line you might not know, but you want to have a value add today, and choose the decisions which can work for you today, but thinking long term. Take small steps so that if you have to replace, you should be able to replace it in the long term. So there are many tools available, many languages, frameworks are available. Postman is there. You can write scripting in that. Node.js has multiple support for testing frameworks. The mean stack ecosystem. Python has their own set of tools. And so is Java. They have Rest Assured or WireMock or other tools are there. Libraries are available. But important thing to understand is that there's a difference between a library and a framework. Framework is up to your decision how you want to do it, but libraries are there for a specific task. So just keep that in mind as you thinking about it technically.
Awesome, great. So we have some appreciation coming in chats. People are saying thank you for sharing your knowledge.
And my pleasure.
We also thank you. So to the audience, you can go to the live.gitcommit.show and show your appreciation by clicking that clap button, and it gives us feedback about the talk and about how we are doing, and also to the speakers how they are doing. So please do use that. Clap as much as you want. If you really like it, then clap more. And also there is a feedback button just below that clap button where you can submit your feedback. It could be about how we are organizing or about the speaker, and about this presentation I think has covered many questions already which people might have had. So Sarthak has covered systematically all the questions which people might come up with. So right now we don't have any more questions. So
sure. And if anybody wants to reach out to me, I'm available on LinkedIn or Twitter. Please feel free to reach out to me, and I'll be more than happy to share my experiences, suggestions to my developer community.
Awesome. Perfect. Thanks a lot, Sarthak, for joining in. So this will be the end of the talk. I look forward to see you again. And one more thing is about the presentation. If we will share the presentation on our GitHub, so if you can share that, then we will put up on the GitHub git-commit.show. There you will find all the presentations by the speakers. So thanks a lot once again joining in, and have a good weekend.
Thank you. Bye-bye. Thank you, everyone. Have a good weekend. Stay safe.
Bye-bye.